Hi everyone, let's try to solve another problem on isometrical projections. We have the question like this. A hemisphere of 40 diameter is supported coaxially on the vertex of a cone of base diameter 60 and axis length 50 The flat circular face of the hemisphere is facing upside. Draw the isometric projection of the combination of solids. Here in this question we have two things. One is a hemisphere of 40 diameter and a cone of base diameter 60 which has an axis length of 50 So first let's try to draw a cone of base diameter 60 So for that we'll take a line, we'll take a normal line. First we'll draw a square of 60 that is an isometrical square. So I'll start it from here. We'll give the length as 60, enter, angle as 30, enter, again 60, enter, angle as 150, enter, length 60 minus 150 angle, then 60 minus 30, enter. Now we have this isometrical square. Now we'll connect the ends of the corner from here till here, then from here till here. After this, from this particular end of the line, we'll connect to the center of the opposite side like this. As you can see, when we move the cursor, you can see the dot coming at the center. Now we'll connect it out here. Similarly, from here to the opposite side, from here to the opposite side, and from here to the opposite side. So once we have this done, we'll zoom this particular area so that it is more clearly visible. So we can draw the ellipse. So how do we draw it? So we have these two commands. One is tangent arc and arc by 3 points. I'll show you both the methods. First, arc by 3 points I'll show you. Click on arc by 3 points. We'll change the line as visible from the end of this line to the end of this line, and we'll make it tangent to any one of the line and click it. Similarly, here also I will show you from here till here and make it tangent to any one of the line. Now we'll do the other method, that is the tangent arc. So we'll click on tangent arc. Now I will click on the end of this particular line, sorry, not the line, the arc, and the end of this particular arc and tangent to any one of the line. Even you can use the arc by 3 points for this also. We'll do it on the opposite side from here till here, tangent to any one particular line. So this actually makes the base of the cone. So to make it more easier, we'll make a copy of this particular ellipse that we have drawn. So we'll select it, we'll press hold the control key, click and drag it out. This makes a copy of the base that we have done. Now I'll zoom this particular thing that we have drawn first. We'll trim these excess lines to draw the axis length. So I'll change the line to center. From this particular point, from the center, we have an axis length of 50 Press enter and we'll place the line out here. Now change the line to visible and connect to the end of the arc so that it makes a cone. Similarly, tangentially to the end of the arc. Now we have this particular things extra, so we'll delete the excess lines which are not necessary. Now we'll fit it out. So if you measure the distance, you can see here we have this as 60 and here also we have it as 60 Now to draw a hemisphere of 40 so we have to scale this down. How do we scale it? So we'll select this particular ellipse and we'll take the scale, then we'll give the scale command as 40 divided by 60 and hit enter. Now place it here. You can see the dimension has changed to 40. So I will delete the dimension as it is not necessary. Just for the representation purpose I have done it. Now we'll zoom this and we'll make it as a hemisphere. Now take arc by 3 points or tangent arc, any of the command. Click at the center of this particular arc from downwards to the center of the other side, and this makes the hemisphere. Now select this particular hemisphere and use the move command. Click at the end, that is, I'll zoom it. Click at the end of this particular line or the corner of this and place it on top of the cone here. This actually completes the problem. So after we do this, we have to select the entire thing, then we have to scale it down to 0.8164. So you can see the reduced size of the problem. Place it anywhere on the screen, and if you want, you can show the angles by drawing a reference line at the base. You can draw a reference line out here, show an angle of 30° on this side, and similarly onto this side. Here we have another method also. So we have places by copying. Either you can draw a square and then do this particular hemisphere separately. So this actually completes the problem.